Imagine that every iron atom in your and my body come from a star that exploded long ago. 4.6 billion years ago, these elements converged, forming the Earth beneath our feet. And all this is just the beginning of a much larger story. In the first 3 minutes after the birth of the universe, the temperature reached tens of billions of degrees. Only the two lightest elements, hydrogen and helium, were created. Subsequently, the universe cooled rapidly. The first generation of stars lit up under the action of gravity. In their hot cores, hydrogen atoms gradually synthesized heavier helium through nuclear fusion. When a star exhausts its fuel and undergoes violent collapse, carbon, nitrogen, oxygen, and other elements vital to life begin to form inside the star. When a massive star exhausts its fuel, its core collapses in an instant. The outer layers are violently ejected, with brightness surpassing an entire galaxy. This is a supernova explosion. At this moment, atoms inside the star are rearranged under extreme temperature and pressure. Elements heavier than iron are rapidly synthesized here. The shockwave from the explosion carries these newborn heavy elements, including the iron in Earth's core and the iron in our blood, hurled at high speed into interstellar space. These elements mix with hydrogen and helium to form new interstellar clouds. The next generation of stars and planets will be born from this recycled material. Astronomers precisely reconstruct this process by analyzing the spectra of supernova remnants and the isotope ratios in meteorites. Without supernovae, there would not be enough complex elements in the universe. About 4.6 billion years ago, a cloud of interstellar dust and gas rich in heavy elements began to slowly rotate and collapse under gravity. The center gradually formed a young sun. In the surrounding material disk, dust particles collided and merged, gradually growing into planetary embryos. Earth experienced intense impacts in its early days. One of the most important was known as the Late Heavy Bombardment. A large number of asteroids and comets impacted the Earth's surface. These impacts not only shaped the moon, but also brought large amounts of water and organic molecules to Earth. Early oceans and atmosphere were thus formed. Earth was not suitable for life from the beginning. It took billions of years of physical and chemical processes to gradually acquire the conditions of liquid water and complex chemistry. These conditions are the foundation for all subsequent stories. The abundance of elements like carbon, oxygen, and iron in the universe is not entirely random. They are the inevitable result of stellar evolution and supernova explosions. But Earth's ability to gather enough of these elements and form liquid water oceans involved the superposition of multiple accidental factors. Scientists reconstructed this process by analyzing meteorites, lunar rocks, and Earth's internal structure.
This structure is a perfect match.
But many
Let's run the
details
final
remain
simulation.
uncertain. Importantly, these conditions were not designed for life. On a cosmic scale, environments similar to Earth may not be rare. The story of Episode 001 only provided the most basic material preparation for the emergence of all subsequent life and civilizations. These elements provided Earth with the possibility of rocks, oceans, and complex chemistry. But from inorganic molecules to the first self-replicating life, there is still a huge gap to cross. A Global History,
Prepare
Episode
for the next
002,
chapter
The
as we
Charm
unravel